Hello, this video is about section 1.4 in the Big Ideas Math textbook, and it's about the divisibility rules, which isn't necessarily in the textbook, but the idea is presented in the Record and Practice Journal. And there's an activity on page 15 that you could do. So I'm going to start off with some notes. Talk about what I mean by when we're asking whether a number is divisible by another. What we're saying is the number can be exactly divided by the other so that there is no remainder or the remainder is 0. When you divide, the result should be a whole number, right? So we don't want any decimals or fractions in the quotient. For example, 10 is divisible by 2 because the result is a whole number. 10 divided by 2 is 5. So knowing how to quickly tell if a number is divisible by other numbers is going to help you with number sense and later with simplifying fractions. And once you understand divisibility rules, simplifying fractions becomes super easy. Okay, so this is the activity that I want you to do in the Record and Practice Journal. It is on page 15, and you should pause well, I'll go through the instructions and then pause the video and see if you can look for some patterns. So here's what we do. I'm going to highlight all the numbers that are divisible by 2. I'm going to put a box around all the numbers divisible by 3. I'm underlining the numbers divisible by 5, and I'm circling the numbers that are divisible by 10. Go ahead and pause the video, and then I'll show you on the next page what mine looks like. So it looks like this, right? And so what you should notice is that there are some patterns, right? So you should notice that, for instance, all the even numbers, right, the numbers divisible by 2 are all in these columns. And then, of course, the numbers divisible by 5 happen to be in this column and in this column. And the numbers divisible by 10 also, right, are just in this column. So there's some other really cool patterns you might notice. You might notice that the 3s, the numbers in boxes, makes a diagonal. And it's kind of interesting that this row right here turns out to be multiples of 9, right? 9, 18, 27, 36. And that has to do with not a coincidence, but I'll show you the rules of divisibility for 3, which all of the digits of when you multiply and get the product for 9s and skip counting by 9s, these digits add to 9. These add to 9. They all add to 9. It's a really cool pattern. Okay, so now we're going to talk about some rules. Well, first, here's some of the things you may have noticed, right? The things that I said about the columns, and there are other patterns that you can look for, and we can go through those another day. So what I want to talk about is the rules. And these rules, it's not that you have to memorize them, but they're in a chart, and you should be thinking about them as you're looking at factors and trying to divide out factors. So you can divide by 2. We're starting here on the left. You can divide by 2 if the ones digit is 2, 4, 6, 8, or 0. So the idea is it has to be even. So for example, the number 24, right? The ones digit is a 4, so I know it's divisible by 2. Going on to the next number, you can divide by 3 if the sum of the digits is divisible by 3. And so here's my example. I'm going to use the same number 24. When I take 24, I add the 2 plus the 4, it equals 6. And 6 is divisible by 3. We're going to skip 4s and 7s and 8s for now. The 5s, you notice that there was columns. The ones digit has to be 0 or 5 for a number to be divisible by 5. So for example, 35, and I underline the 5. 35 is divisible by 5 because it ends in 5. For 6, it's really cool. The number is divisible by 6. The number is divisible by 6 if it's also divisible by 2 and 3. So here's my example. I'm going to use the 24, right? If I underline the ones digit, is it divisible by 2? Yes, it is. It's even. It ends in a 2, 4, 6, or 8. That one works. Now I'm going to check to see if it's divisible by 3 by doing the rule where you add the sum of the digits. 2 plus 4 equals 6. And yes, it is divisible by 3 because 6 is divisible by 3. So as long as a number is divisible by 2 and 3, then it's also divisible by 6, which kind of makes sense because 2 times 3 is 6. All right, for the 9s, again, you're looking at the sum of the digits, which is kind of a weird thing. For 9s, though, the sum of the digits has to be divisible by 9, right? So I can give you an example like this. 135, I add 1 plus 3 plus 5, and that equals 9. So I know that the number 135, because the digits add up to 9, which is divisible by 9, so is the number 135. Now for the 10s, the one digit has to be 0, right? That's the only option. And here's an example, 350. It ends in 0. So now let's try some examples. Take the number 108. I'm going to ask you to use divisibility rules to determine if it's divisible by these other numbers. So I'm going to start with 2. And I just look at the 108 and I underline the ones digit and I go, yep, it matches because the ones digit is 2, 4, 6, or 8. There it is. So I'll say yes, ends in 8. Takes care of 2. Now look at 3. What I do is I add the 1 plus 0 plus 8 because I'm adding the sum of the digits and I get 9. And 9 is divisible by 3. So I'm going to say yes, 3 goes into 108 evenly. Let's move on to 5. I look at the 108. I underline the ones digit. Oops, it has to be 0 or 5 and it's not. And I'll say no, it ends in 8, not 0 or 5. And now I'm going to do the 6s. So remember for the 6s, I have to figure out if it's divisible by 2 and 3. So I go up to this row. Yes, it's divisible by 2. Yes, it's divisible by 3. So I say yes. Divisible by 2 and 3. Check. Now I'm on to 9. Remember 9, I'm also going to add the sum of the digits. 1 plus 0 plus 8 equals 9. So I can say yes. And the last one is 10 and 108. I underline the 8 and I'm going to say no. Ends in 8, not 0. Okay, so the last part of it is I want you to try to use the rules of divisibility to tell if the 6 numbers can evenly go into 1,620. Go ahead and pause the video, try it, and then I'll show you what I got. Okay, so I write 1620. I'm going to underline the ones digit, and I'm going to say yes. It ends in 0, right? The ones digit is 0. Now I'm going to check for divisibility of 3 by adding all the digits together. 1 plus 6 plus 2 plus 0 equals 9. And 9 is divisible by 3, so the answer is yes. For the 5, I'm going to underline the ones digit. As long as it's 5 or 0, it's divisible by 5. So this one is yes. It ends in 0. Now I'm going on to 6. I look at my divisibility by 2. Yes. 3 is yes. So for 6, it's yes. It is divisible by 2 and 3. Now moving on to 9. Oh, just like 3, I add all the digits. Check it out. I already have it added. 1 plus 6 plus 2 plus 0 equals 9. Yes. sum of digits is divisible by 9. Having a challenge with the dots for the I. All right, the last one is 10, right? What's my number? 1620. Underline the ones, please. Yes. It ends in 0. Okay, that's it. Those are the basic rules of divisibility. There are some for other numbers like 4 and 8, but we'll go over those in another time. Good luck.